Now we're ready to do number 2 on Displacement Notes and Practice. And number 2 is the last part of the notes. Then you will be ready to go on and do numbers 3 and 4 on your own. So number 2 says, an airplane has displacement d1 as it travels the first leg of its journey. And this is showing that displacement of the airplane as it leaves its first location and starts on its journey. And it has displacement d2 as it goes from there to its final destination. So once it gets to its first location, its displacement after that looks like this. Part A says determine the magnitude and direction of each displacement using this scale and coordinate system. So we're given a scale here that's going to enable us to convert this drawing into an actual number of kilometers. So to do that, we need to measure this vector. This is kind of the reverse process from what we did in number 1. And go ahead and measure along with me. You can pause the video if you need to and complete this on your own page. So I'm getting 7.2 centimeters. Now we need to know how many kilometers that is. So in real life, how many kilometers did it go? So I'm going to multiply by this scale factor, and I want the centimeters to cancel. So I'm going to put the centimeters on the bottom and kilometers on the top. And multiplying that out now, I'm going to end up with kilometers because all the other units have canceled. And 7.2 times 1,000 gives me 7,200 kilometers. Okay, so this is the magnitude of this displacement vector. The second thing we need to know is the direction of the displacement. And this is a different coordinate system here. This says 0 degrees is the positive x-axis, and angles are measured counterclockwise. So that's meaning that if this is your coordinate system, this is the positive x-axis. So that's 0 degrees, and angles are measured going around this way. So let's take a look here at displacement 1. Put our ruler on the coordinate system, and if there wasn't already a coordinate system there, you can just sketch it in. But make sure you're putting your protractor on the tail of the vector, not on the tip. Okay, so I need to measure from 0 degrees going around. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 1, 2, 3, about 133. Another way to figure out the angle, if you don't want to count from 0, and your protractor might have all these numbers on it, but really be sure you're thinking about the numbers, the angles as you go around. You could just say, well, I know that from here to here is 90, so I'm just going to measure on my protractor this amount, and then I'll add them together to get that total. So the way we would write this displacement is displacement 1, and the way you show that you are specifying a vector is you put an arrow over the top of it. So I'm writing the magnitude, and now I'm writing the direction. Okay, so that is our first displacement. Now we need to do the second displacement. So let's measure the length of it. 10.2 centimeters. So 10.2 centimeters, and now I need to convert that to kilometers to find out the real magnitude of the displacement. And multiplying 10.2 times 1,000 gives me 10,200 kilometers. So that is the magnitude of this displacement vector. Now I need the angle. So the angle, remember, measure always from, this is 0 degrees, measure counterclockwise all the way around until you get to the vector. Well, my protractor does not go all the way around past a half circle. So what I'm going to do is realize that from here to here is 180 degrees. And then using my protractor, I'm going to measure this little angle here. So to do that, I put my protractor upside down and line it up on there. And then I'm going to start here and measure down until I get to my arrow. So this is 10, and this would be 20, so it's looking like about 18 degrees. Okay, so the total angle is 180 degrees plus 18 degrees, which is 198 degrees. So displacement 2, let's write it right here, is 10,200 kilometers at 198 degrees. And this coordinate system for measuring angles is the one we will use the most. Every once in a while you'll see something that says, you know, east of north or whatever, but usually this is what we will do. So really work on getting this down on this assignment. Now we are ready to do part B, which says draw a vector diagram on graph paper that shows the airplane's journey. You will need to start by drawing displacement D1, that is this vector, and then go from there and draw displacement D2. Label each vector on your diagram. So take your piece of graph paper, and whenever you're going to start drawing a vector diagram, you want to think about your vectors so that you don't end up running out of paper. So I see that vector D1 goes up and to the left, so I would not want to start my diagram up here because I will end up off the paper right away. So I'm going to start maybe halfway down the paper over here on the right side, and wherever you start, it's a good idea to write that is your starting point. And because you're going to be drawing this vector, you need a coordinate system. Well, anytime you draw any vector, you need a little coordinate system to measure your angle from. So I'm going to first figure out the direction. It's 133 degrees. So starting from here, I'm going to put my protractor on my coordinate system and measure 133 degrees from over here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 133 is right here. And be as precise as you can. And make a little mark to remind you of where that is. This is going to be the direction of vector D1, but now we need to make an arrow to represent it. And that arrow is going to be a length of 7.2 centimeters because that's the scale that we're using. You can't draw a vector that's 7,200 kilometers long. So I'm going to turn the ruler around so that the 0 centimeter mark is here and draw an arrow that's 7.2 centimeters long. Be as precise as you can, making the very point of your arrow end at 7.2 centimeters. Once you've drawn a vector, it is a really good idea to label it. This is 7.2 centimeters, and I'm going to label the angle was 133 degrees. Okay, that's vector displacement 1. It says then go from there and draw displacement 2. So if you think about what's happening, the airplane starts at one city, and in the first leg of its journey, it ends up here at some other city. Now it's going to fly to its final destination, and that displacement is given by this vector D2. So from here, I need to draw this vector. Not from the start, because the airplane is not there. The airplane is here now, and it's continuing from there, this distance, and in this direction. So I need to draw vector D2, which is at an angle of 198 degrees. In order to measure that angle, you need to make a little coordinate system at the place you are going to draw the vector, which is right here, because that's where my last vector ended. That's where the airplane is. So an angle of 198 degrees, it's going to start here. This is the 0 degrees always in the coordinate system. And it's going to go around, and it's going to go past 180 by 18 degrees. So to measure that, I'm just going to measure the 18 degrees below this axis. So turn your protractor over and measure 18 degrees. So 10, 20, so 18 is right here. Make a little mark. Now we need to draw the arrow to represent it, and the arrow needs to be 10.2 centimeters long. So starting at the 0 and going out to 10.2 centimeters. It's also really good to have a sharp pencil when you do this. So this is displacement 2, which is 10.2 centimeters, and label the direction to, this was 198 degrees. So now we've finished part B, which shows the journey of the airplane. First it has a displacement to this city, then it has this displacement to its final destination. So this is our endpoint. Part C. On the same diagram, draw the vector that shows the overall displacement for the entire journey. This vector is called the resultant because it is the result of adding together the other vectors. So this is, we're finding now the total displacement of the airplane. Remember, this is not the total distance traveled, right? Total distance traveled is going to be much longer than how far it is from where it started. Displacement, overall displacement for a journey is, at the end, where is it relative to where it started, not how far did it go on the way to get there. So to draw the resultant, you need to draw the vector that goes from the very beginning point where the airplane started to the very end point. And this is going to be an arrow because it has a direction. Make sure you put that arrow tip on the end. So this is the total displacement. Part D says measure the resultant displacement in centimeters. Use the scale and coordinate system to find the actual magnitude and direction of the overall displacement. So now we need to find this displacement. What is the magnitude of it and what is its direction? So to find that, we need to measure it in centimeters from the start to the end. This looks like it is 14.9 centimeters. So the total displacement equals 14.9 centimeters, and yours might vary a little bit depending how accurately you and I drew our diagram. Now this is not the actual displacement of the airplane. We need to convert now to kilometers using our scale. So 14.9 centimeters multiplied by our scale, which is 1 centimeter equals 1,000 kilometers, gives us, is 14,900 kilometers. Now we're not done because this is only the magnitude of this total displacement vector. We need now to find the direction. Remember, every vector has a magnitude and a direction. So let's find the direction. To find the direction, we need the angle, and remember that angles are always measured at the tail of the vector. So this vector, the tip is here, the tail is here. So this is where we measure the angle. So starting at 0 degrees, we're going to go all the way around until we get to that vector. That's the angle that we need. So I'm going to just know that this to here is 90, and I'm going to measure this additional part and then add those together. So 10, 20, 30, 40, 50, 60, 70, 83 degrees. So from here to here is 83 degrees, and I'll add that to 90. So 83 degrees plus 90 degrees is 173 degrees for the direction. So now we're ready to write our result that the total displacement of the airplane is 14,900 kilometers at 173 degrees.